Okay, I just want to review real quick the simple Iupac naming rules. That one thing we're going to always want to do is name based on the longest chain, but we want typically the longest chain. If we have typically we want the longest chain, and then we're going to take preference. We're going to number these guys, give it the lowest number, but we're also going to try to name these guys based on our different functional groups, and different functional groups take priority. If we have a choice to name a ring versus a chain, and all things equal, the rings will typically take preference. But if the chains have some of these key functional groups like oxygen and nitrogen, oftentimes the chains take preference over the ring. So we're typically going to want the longest chain, give it the lowest number, and I put our substituents in alphabetical order. Remember what our substituents, the numbers meth, eth, prop, and bute are the only really hard ones. They were determined a different way. They're named more of how they were discovered with butanoic acid, had to do with like how it was coming from, I think, rancid butter and propionic acid. Just these guys came from when they're originally discovered. That's why they have the unusual names. But pent, hex, hept, oct, non, dec, undec, dodec, tridec, and keep going down. All those are pretty straightforward. The only thing to note when naming, we have isopropyl group, which is not named under P, it's named under I. While isobutyl could be named under methylpropyl. But tert-butyl and sec-butyl are still named under butyl. Tert-butyl and sec-butyl, which is are still named under the butyl group. Generally, when we name these guys based on their functional groups, the more oxygen bonds and the more terminal it is, the more important it is. So carboxylic acid, which is by all means a terminal chain, takes preference over acid derivatives like that don't have to be terminal chains, like esters and amides and acyl chlorides. They take preference. Acids take preference to that. There's nitriles, which is a triple bond to a carbon. That's also very terminal. From there, we have aldehydes, so these are more oxidized. We're getting less oxidized. Ketones and ketone derivatives. Less oxidized alcohols of all types. Amines of all types. Between amines and that is peroxides. And then we get into pi-bonded systems, regular alkanes, and at the very bottom, ones that don't really matter are ethers and halides. Those are not going to be how we determine the numbering. So let's count the longest chain on some of these examples. I'm just doing them fresh. Is this longest chain 1, 2, 3, 4, 5? Probably not. 1, 2, 3, 4, 5, 6. Oh, that could be a long chain. 1, 2, 3, 4, 5, 6. That could also be the longest chain. This one if I count from here to here, has 3 substituents. Count from here to here, there's 2 substituents. So I'm probably going to name it the one with 3 substituents. 1, 2, 3, 4, 5. Say 3, 4, 5. But if I name from here, 1, 2, 3, 4, I get 2, 3, and 4. The longest. So there's all alkanes, so there's going to be a hexane. I have a substituent at 2, a meth, an eth, and a chloro. So chloro comes first, so I'm going to have 4 chloro, then 3 ethyl, 2 methyl hexane. Moving on here, longest chain. I want this guy to have, this guy takes preference over this guy, so I want that to be the lowest number. 2, 3, 4, 5. So I think this is going to be what? That's a methyl, hydroxy, so this would indeed be the lowest number for the highest priority. So a ketone is the pentane becomes pentanone. That's going to be a 2-pentanone. Because of that, we have 5-hydroxy, 4-methyl, 5-hydroxy, 4-methyl pentanone. So we're always going to try to keep the higher priority at a lower number. Here we have a ring. We're going to call that, this is a 6-member ring, so it's a cyclohexanone. Cyclohexanone. Because of the nature of this, we do not have to number that. You could leave it as 1 cyclohexanone, but we're always going to try to give it the lowest number. So the derivative here is an isopropyl, so I'm going to call it 2 isopropyl cyclohexanone, and that's understood. Yes, we have a benzene. The benzene is longer and more important than chlorine, has no importance. So this is just going to be a 2 probably chloropropyl, because it's a 3-carbon chain, benzene. 2-chloropropylbenzene is how I would probably go about naming that guy. So the only difference in how I would do that is maybe put that in parentheses to say that 2-chloropropyl is, it's 2 off the propyl. Now this guy has an amine in the long chain. So this no longer is a benzene, but a phenyl derivative. So we'll have 1, 2, 3, 4, 5, 6. So that's a hexanamine. 1 hexanamine. And at the 4th position, this is when we have a benzene that changes to a phenyl. So 4-phenyl 1-hexanamine is how I would go about naming that. Thus we have a carboxylic acid. 1, 2, we'll say 3, 4, and we have, so 3 cyclobutyl butane, and it goes to oic acid. We haven't learned some of these yet. But the idea here is preference. In this case, we have disubstituted benzene. When I have a methyl group, it becomes a toluene. But when we have an alcohol group, it becomes a phenol. We'd rather name this methylphenol than hydroxytoluene. So alkanes always take the back seat when we have a higher group. So we'd call it either ortho methylphenol, or you could call it 2-methylphenol. 2-methylphenol. So the key is to remember, 1, we want the longest chain. 2, we want to number these so that the highest importance functional group gets the lowest number. That's where we're going to start our numbering system. We're going to oftentimes try to number this so we have the lowest set of numbers. But for example, like if I can label that 1, 2, but I'm going to label that 2, 1. If I have something like this, I could call that 1 here, down here. I could call this 1, 3, 4, but I could also call this 1, 2, 4. 1, 2, 4 is going to be more important, but also we want to give the chlorine the lower number because it's of lower importance. So hopefully some of this will help refresh some of our naming. If we have I'll do one more. Let's just have alkene. So 1, 2, 3, 4, 5. That's a pentene. You have to label it's between the 2 and the 3 carbon, so it's going to be 2-pentene. And then so 5-chloro-2-pentene. Try to give the alkene the lower number because pi bonds are more important than sigma bonds.